In this lecture, we're going to go through the mathematical process in which we calculate the Pearson product moment correlation coefficient, or in other words, the R statistic. And what we see here is the equation that will be used in order to compute the R statistic, and we'll work through an example. Now you'll see only three different variables that are entered into this equation. X is the predictor variable, sometimes referred to as the independent variable, and we'll go through this example shortly. Y is the criterion variable that is often referred to as the dependent variable, and you'll see that the Y variable appears throughout the equation. And N refers to the total number of participants or the total number of scores. And for each participant or each score, there is a pair of scores. So we have a number of XY pairs. And we're going to go through an example here in which we're going to pair exam grades. And so the question here, is there a relationship between first year Introduction to Anthropology grades and second year regional ethnography final grades? And so these are hypothetical data that were summarized for 7 students. So our N in this problem is 7, as we have 7 pairs. One is the X, which is our predictor variable. Y, once again, is our criterion variable. That is the score in the second year course as compared to the score in the first year course. And N refers to the total number of participants or the total number of XY pairs. And so once we start, before we even begin to think about performing any calculations, we need to establish which one is the predictor and which one is going to be our criterion. So can we predict the outcome of the second year course based upon the outcome of the first year course? And so in order to perform this calculation, we set up a table, and we have what are called the raw scores. So these are scores that have not been processed. These are scores that were obtained from each student for each of the 2 courses. And the first step is, once we make this table, we sum all of the scores for X vertically, and we add up all the numbers, and we place the answer in the cell beneath the row for the last participant. And recall that uppercase Greek letter sigma is the symbol used for summation, which is arithmetic addition. And we do the same thing for the predictor variable raw score, for the criterion variable raw scores, where we add up all the scores, so 80 plus 85 plus 83 plus 85, so on and so forth, and we simply just write down the final answer of all those additions. We then move on to the next column over, which is the X squared. So when we start populating these cells here, we just take each raw score, and in this case it's the X. So the X score for the first research participant, and we square it. So 50 squared, 50 times 50 is 2500. We then move to the next column, which is a Y squared. So we go to the raw score for the first participant, and we find out that the raw score is 80. 80 squared is 80 times 80, so 6400. And in the final column, we have XY, which is X times Y. So the X variable for the first participant is a 50. We multiply that by the paired Y score, which is 80. 50 times 80 gives us a score of 4000. The next step is to add up all of these squared X values. So we repeat this for 56 squared, 52 squared, 57 squared, and then we add all of those up, and we place the final summation value in this bottom cell in row number 9. The first row is the row with the headings, the second row contains the score of the first student, so on and so forth, and we add that up, and we do the same thing with y squared. We take the 85 squared, we place it in this cell, 83 squared, place it in this cell, so on and so forth, and then we add up all of the y squared values, we place the answer in this cell, and last we do the same thing with xy. So 56 times 85, we put the answer in this cell. 52 times 83, we place the answer in this cell. And once we've completed that process, we add up all the numbers and we place that value in this cell here. So now would be a good time to pause the video, perform all of these calculations, and then restart the video, and we'll move on to slide 16, where we have the answers to put into our Pearson equation. So assuming that you are now restarting the video from pausing it and working through the calculations, we move on to slide 16. Remember that we're going to put those summations in this final column, or in these final cells of this row. And we have the summation of x squared, the summation of y squared, and the summation of xy. And we see the appearance of all of those variables in this equation. So when tackling this equation, what we want to do here is focus on each of the variables one at a time. So if we start with the numerator, we see n. N refers to the number of paired scores. And in our example, we had 7 paired scores. So you would just put a 7 here. The summation of xy was the number calculated on the far bottom cell, the far lower right-hand cell in our table on slide 15. So we performed all of the xy calculations for each score, added them up, and it gave us a summation of xy. That value we put into this equation, and then this value will be multiplied by 7, or the n, depending upon the study. And then we have the summation of x, we have the summation of y, and those two numbers will be entered here and will be multiplied by each other. Moving to the denominator, we see that we have a number of calculations that, when completed, we would then take the square root of that final number. But before we do that, we work within the square brackets, and within the square brackets we see, once again, we have n, which is 7. We multiply that by the sum of the x squareds. So the third column with the numbers, rather the fourth column, the x squared column at the very bottom, when we added up all the x squareds, that's the number we put in here, and we multiply that by n. This is a little bit different here, where we take the sum of all the x values. So the x values are the raw values for the predictor variable, the raw scores for each of the 7 research participants. Those scores are added up, then they're squared, paying attention to the parentheses here, as opposed to what we saw over here, where we take the sum of all the scores that were squared first, then added up. And we see the same operations exist for the criterion scores, where the scores, each criterion score for each participant is squared, then they're all added up, as opposed to adding up all the raw scores first and then taking the square value. So when we work these calculations, we transfer all of the values from our table into the equation. And so we have a lot of numbers here. Paying attention and adhering to your order of operations, your final answer should be 0.98. This is a value that should exist between negative 1.0 or positive 1.0. So if you have a value that's outside of those limits, you know that there was a calculation error. But this is the correct answer for this particular problem. So in conclusion, we would say that there is a strong, we say it's strong because it's a value very close to 1.0. This is a very strong correlation, and it's a positive relationship. So it is a positive value. The value could be a negative value. So if you get a negative answer with different problems, that is entirely possible, but the value cannot be less than negative 1.0. So you can't have negative 1.2, for example. But in this problem, we conclude that there's a strong positive relationship between first-year anthropology grades and the second-year anthropology course. Now, there are some inherent limitations of using the Pearson product moment correlation coefficient. The first potential problem in using this approach is that the range of the data could influence the outcome. So if the range of the scores is low, in other words, if the variability is low, it's really going to be difficult to detect a relationship if one truly exists. And so expanding the sample size will be beneficial here to include a larger range of potential scores in order to determine if there is a predictive relationships. Two groups that have no relationship could potentially produce a strong correlation. So it's very important to understand and highlight the fact that correlation and regression is not cause and effect. This could come through just simple coincidental occurrences of scores. Extreme data points is what we'll address a little bit later, but extreme data points, even only a few of them, can exert a large effect, and we refer to these sometimes as outliers. As we'll learn a little bit later, there are actually two different terms when referring to these extreme data points. The first that we'll address are what are called outliers, and outliers will reduce the strength of a correlation. Although we won't define it on this slide, and we'll touch on it later, the second type of extreme point is referred to as a leverage point. And a leverage point can have the same effect in reducing the strength of a correlation. The relationship could be present. This should be number 4 here. But the relationship could be present, but not evident from the Pearson product moment correlation, since the relationship is not linear. So a relationship between two variables could in fact exist, but the nature of the relationship is best described in a nonlinear fashion. But going through the calculations as we have, that assumes that a linear relationship exists between the two variables. And so in that situation, our approach in calculating the R statistic will be very limited. So this ends this video on how to calculate the R statistic.